All right. So on this problem, you're going fishing Walnut Creek near Erie, Pennsylvania for steelhead trout. A lot of distracting information provided. You're using a 9-foot, 7-pound ugly stick rod. Has nothing to do with it. You're casting salted minnows on a number 10 hook. Doesn't really matter. On one cast, I sent a bait out at an angle of 39 degrees. That's probably important. And that's above the horizontal. And the bait reached a height of 4.3 meters above the end of the rod. What was the initial speed of the salted minnow? So assume there's no drag or air resistance so that it is a projectile in free fall. So I'm first going to draw. So it starts from here. It's going to go up and back down, right? And land. It'll probably land in the water down here. So this is where it's launched from at some initial velocity, VI, at some angle theta. And it reached a height of 4.3. So where do you think that is? Anybody want to say? Max height. Right. It's probably right here. That's where y equals 4.3 if this is where y equals 0. So that's the end of the rod when it releases the bait, and then it flies up in a parabolic arc like all projectiles do and reaches that height of 4.3 meters, which is pretty high actually. That's like 12, 13 feet. That's pretty high up in the air. Anyways, let's see what we know. So we're going to say that's the beginning of the motion. This is the end position of the motion. So this will be the beginning of time, right? Time initial 0. This is time final. We've got a velocity initial at some angle, but we don't know that velocity. We do know that angle. Now with all projectile motion, we very likely are going to have to find a Vy initial and a Vx, a Vx. Those components. What else do we know? It's free fall, so the acceleration is 9.8. Well, we only know we have to analyze some interval of this motion, so we need a beginning and ending point. The beginning is pretty clear. It's when it left the rod. The ending is going to be this highest point because that's the only place we know anything about. So that's 4.3 meters. So I'm going to look at what information I have in the x and y directions for that. The velocity initial in the y, I don't really know, right? But I do know something. I know the angle's 39. I know that this is going to be that the y initial velocity in the y direction is going to be the initial velocity times the sine of 39. I know that. As a matter of fact, that initial speed, that is this number. That number is the initial speed. The final y velocity, it doesn't tell me what that is, but you should know what it is. Anyone know what that final y velocity is there? Mark?
0.
It's 0 because it's the highest point. So that's 0. The y velocity becomes 0 at the highest point. The y component of the velocity. Y initial, I call it 0. Y final is higher. It's positive 4.3 meters. Acceleration in the y direction is negative, is downward directed 9.8 meters per second squared. And the change in time we don't know. All right, this is what I want to find. I want to find that. I know a lot of things. There's only one thing I don't know. So maybe I should avoid that. I don't know that, don't want it. This is what I want to find. It's the only thing I'm missing. I don't even think I need to do the x's because I have so much information. So I'm going to try that. Now the equation without time is Vy final squared, or V final y squared, equals V initial y squared plus 2ay y final minus y initial. The change in y. So I'm going to plug in things. You can rearrange this and find V initial first. I think today I might do that. I'm going to rearrange this algebraically for that. So I'm going to have that VIY squared is going to equal VYF squared minus 2AY YF minus YI. So this is what I'm looking for. Actually, part of that, right? That's this. VY squared sine squared of 39. So I squared that whole thing. I kind of took a shortcut, or I did two pieces of work. I subbed it in and I distributed the square. And remember, I'm looking for this V initial. That is the speed. And the final is 0 minus 2 times negative 9.8 times 4.3 minus 0. All right. I always get concerned when I got negatives in there and stuff. Is things going to work out sign-wise? So I see I got two negatives going to be a positive, because this square can only be positive. So VI squared is going to equal, I can distribute that through, that's 19.6. 19.6 times 4.3 over sine squared 39. So V initial, which is the speed, is the square root of all that. 19.6, 4.3, sine squared 39. Plug that into a calculator. Crank that out. .58, 14.6, looks like two significant digits, so 15. VI is 14.59 meters per second, which is 15 meters per second. To two significant digits, which is what I'm provided with. There you go. Not as difficult, but kids have trouble when that, got to find that speed, recognizing that that's that number right there. That the V in the y direction initial is the speed times the sine of the angle. So that number right there tells you the speed. All right, I'll post that on Canvas.